5.1, which should be a refresher. Systems of linear equations in two variables. This was done a long time ago. This is just a review. But we'll talk about both methods. So 5.1, systems of linear equations in two variables. Systems of two linear equations in two variables. I'm sure you remember there are two methods that we can also graph, but we're going to review two methods. One of them is called substitution, and the other one elimination. Substitution and elimination. So let's try the substitution method. Let's look at 14 on page 555. 2x plus 5y equals 1, negative x plus 6y equals 8. I'm asked to use substitution. Question. Okay, what will I substitute for? Will I substitute for x, solving the first equation for x? No, because it has a leading or a coefficient of 2. Not recommended. Should I substitute for y and solve for y? Nope, the coefficient is 5. And then I will have a fraction to deal with. Should I substitute for this one? No, because of the 6 in front. Should I substitute for this? The answer is yes. I can always get rid of positive or negative 1. So from here, I will, let's say, to make it easier, I'm going to move this to this side and this to this side. So this becomes x, and this is 6y minus 8. Or just move 6y and then multiply by negative 1. It's the same thing. So x is 6y minus 8. What do I do next? So I solve the second equation for x because it has coefficient, or it had coefficient of 1 or negative 1. That's how I made the decision. Y or 1 or negative 1. Not 2, 5, and 6. So then, what do I do with this? I solve this equation for x. What for? In order to go back in the second equation and replace that x by 6y minus 8. So then I have 2 parentheses 6y minus 8 plus 5y equals 1. Now this is an equation that I can solve because it has only one variable. So one more time. The method of substitution says find any term with a coefficient 1 or negative 1 and solve for that variable. Now, sometimes you will be able to simplify both sides and divide both sides by a number, and it doesn't matter which one you're going to pick, as long as it has coefficient 1 or negative 1. Is this okay so far? Now we distribute. 12y minus 16 plus 5y equals 1. Combine like terms because now this is linear. 12y plus 5y, 17y. Move 16 to the other side, so y equals 1. But this is not good enough. I have to go back now and determine x, replacing y by 1. So how much is x when I replace y by 1? Negative 2. What is the ordered pair that appears, I don't know for sure yet, that appears to be the solution of the system? Awesome. With a question mark, I'm not certain yet. I go back to the original problem. Replace x by negative 1 and negative 2 and y by 1. Negative 2 and y by 1. So let's check. 2 times negative 2 is negative 5. Negative 4, I'm sorry. 2 times negative 2 is negative 4. Plus 5 times 1. I was already looking at 5. So 5 times 1 is 5. 5 minus 4 is 1. Check. Negative with negative 2 is 2. 6 times 1 is 6. 2 plus 6 is 8. Only now I'll say yes. So now as a refresher, how many possibilities are with these systems? How many cases can I encounter when solving systems of two linear equations? There are three. This is the first case, which is our case. The two lines, this is a line, if you graph it, this is a line. This is also a line, right? They meet in this case in -2, 1. So there is only one solution. Two straight lines cannot meet in 2 or 3. They meet in 1. Here's the second possibility. Parallel lines. How many solutions here? None. And there is a third possibility in which this is the first line, and here's the second line. All the same. So infinitely many solutions. No solutions. Unique, we like to say. Unique, or only one. These are the only three possibilities. Do we need another example with substitution, or we want to refresh our memory on elimination? Elimination, okay. Oh, here it is, 22. We have 2x minus 7y equals 2, and 3x plus y equals -20. Oops, I copied 24, sorry. Okay, in this situation, we're asked to use elimination. Okay, I'm looking at the coefficients, 2 and 3. If I choose to eliminate x, I will have to multiply maybe this one by 3 and this one by -2 to change this into a 6 and this into a -6. So when I add them, it goes away. But let's look at y. Here I have -7, I have 1. In this particular situation, if I decide to eliminate y, I will not have to multiply both equations, but just this one and only by 7. So if I do that, I copy the first equation, and then I multiply the second one, each and every term. We cannot choose and pick and choose. So this is 21x plus 7y equals -140. And now I will add term by term. When I add these two, I get 23x. But I accomplished my target. I got to my target. I eliminated y by adding -7 to +7y. That was 0. So this is -138. So x equals -138 divided by 23. Then what do we do next? So what do we get? What do we have? Is it -6? 8 and 1, 12? Yes, -6. Good. So now I have to decide where to go back. It doesn't matter. So I can go back here and find y. So 3 times -6 is -18 plus y equals -20. So then y will be -2 by adding adding 18 to both sides. So what is the prospect solution? I'm not certain yet. I have no idea. Very good. I don't know till I go back and check. So I'm checking in the original problem. -6, -2. -6, -2, -6, -2. Let's try. 2 times -6 is -12 plus 14. Because -2 times -7 is plus 14. -12 plus 14 is 2. Check. This is -18, and then -2 is -20. Check. Only now I can say yes. This is indeed correct. Any questions? I would like to look at a word problem. And I forgot to number 6, so this is 7. Let's look at a word problem in which we apply what we just refreshed our memory on. Substitution and elimination. The sum of two numbers is 7. 43 on page 555. The sum of two numbers is 7. So can anyone give us any information or anything that we could work with? Yes, the sum of two numbers is 7. That's it. If one number is subtracted from the other, their difference is -1. Find the numbers. Oh, it's already set up. 2x equals 6. X equals 3. If x is 3, how much is y?
So we can answer for how much the values are, but we can't tell which is which, right?
But we will. Because, yes, because 4 minus 3 will not be -1. So they have to be in this order. So 3 plus this will work either way, right? But this will not. So 3 minus 4 is -1. If I mess up and write 4 comma 3, that would be incorrect. Very good. Any questions? Any questions? Any questions? Okay. We are still talking about two variables. 5.4. They're systems with two variables, but they're not linear anymore. Systems of nonlinear equations in two variables. Systems of nonlinear equations in two variables. On page 587, we have substitution and addition, or elimination, same thing. So let's start with, let's say, problem 8. We have x squared plus y squared equals 5, and 3x minus y equals 5. It is a system. It has two variables, but this is not linear anymore because we have x squared, y squared. Okay, and we are asked to use substitution again. What will I substitute for? X squared, I can't, because I won't be able to plug it in the second one. Y squared, I can't, although they have coefficients of 1. 3x, no, because it has coefficient of x. So I'm back to the best option, which is y. I'm going to solve for y. So 3x minus 5 equals y. So I solved the second equation for y. What do you think is going to be our next step? Exactly. But I have to be very careful because now I have to plug in, and it's better to write it first. X squared plus 3x minus 5, everything squared equals 5. And yes, I cannot stress enough, and I know I sound like a broken record. Was there any class in which we did not square binomial? Forgive me. Yes. That's why that was the first handout of the semester. So I copy x squared, but I have to be careful what I do with 3x minus 5 squared. How many terms will I write? 3 terms. The first term squared minus 2. Yes, first multiply 2 by 5 and you get 10. Multiply by 3, negative 30x, and then plus 25 and minus 5 because it's quadratic and I have to set it equal to 0. That's the only difference between linear systems of two equations in two variables with linear systems versus nonlinear systems. So this is 10x squared minus 30x plus 20 equals 0. Of course, I'm going to simplify it. That's one of the key words in math. Simplify and factor. So what will you simplify both sides of this equation by? Yes, so we have x squared minus 3x plus 2 equals 0. And then if it's not easy to factor, forget it and use the quadratic formula. But it's not difficult to factor. Into? Very good. So then x equals 2 and x equals 1. Is this good? Good, but not good enough. Because I have to find the corresponding y values now. Where do I get them from? From here. I plug in 2. 3 times 2 minus 5. How much is y? 3 times 2 minus 5 is 1. The second one, 3 minus 5, because it's x equals 1. 3 minus 5 is negative 2. So now this equation, this system, forgive me, of nonlinear equations in two variables has two solutions. The first solution is very good, and the second solution is no matter how many solutions, I have to go back and check. Okay, so let's check. I'm checking 2, 1 first. 2, 1, 2, 1. 2 squared, 4, plus 1 squared, 1, 5. Check. 3 times 2 is 6, minus 1, 5. Check. I'm checking 1, negative 2. 1, negative 2, 1, negative 2. So 3 plus 2 is 5. Check. 1, negative 2, yes. Check. Only then I'll say yes. There should not be any difficulty. Should not be any concern that they will not work. But the concern is, what if I make an error? So it's not like the square root equations. You can go back and the solution may not work, not because you made a mistake, but because it's an extraneous solution. The same with log equations, right? If the solution is not in the common domain, it would not be a solution. But here, unless there is an error, the solutions will not work. Okay. Let's look at another one. This time at elimination. Let's say 22. 3x squared minus 2y squared equals negative 5. And 2x squared minus y squared equals negative 2. I hope it's very clear here. In the previous example, we were not able to use elimination because the variables are not the same. This one has x squared and this one has x. This one has y squared and this one has y. But in this system, yes, we can use both methods. We can, not for x squared or y squared, but for this one, I can use substitution and solve the equation for y squared. But let's say we want to eliminate. Now, we look at the coefficients before we decide which variable to eliminate, because the variables are the same, x squared, y squared, y squared. So I can use elimination. 3 and 2, if I choose to eliminate x squared, then 2 and negative 3. But look at this one. I have negative 2 and negative 1. What do I need to multiply the second one, only the second equation, by in order to eliminate y squared? Negative 2, because negative 2 times negative 1 will be positive 2y squared, and these two will go away. So I copy the first equation, and I multiply the second equation by negative 2, negative 4x squared plus 2y squared equals 4. These two go away, as expected. Then we have negative x squared equals negative 1. I like it, but not before what? I don't like it just yet. What do I have to do to it? Always remember, simply, yes. Yes, divide or multiply by negative 1. And now I know that I have to get two solutions. And I have a method that is very easy to apply here. which is exactly. But do not forget, always ask yourselves how many solutions. I have to have plus or minus. And now I go back anywhere. It doesn't matter. Let's say we go back with x squared here. 2 times 1, x squared was 1. 2 times 1 is 2, minus y squared equals negative 2. So negative y squared equals negative 4. I like it, but not yet. Have to eliminate the negative. So I have y squared equals 4, and I do the same thing. Y equals plus or minus 2. Now I have to be careful that when x is 1, I have 2 different options for y. When x is negative 1, I have 2 different options for y. So how many solutions, how many ordered pair solutions will we find? 4. So when x is 1, there are 2 options for y, and when x is negative 1, there are 2 options for y. So 1, 2, 1, negative 2, negative 1, 2, and negative 1, negative 2. All will work. And please check. They will all work. Back in the original problem. Please tell me what type of, and we're going to look at the word problem as well. What type of nonlinear systems you would like to practice? Maybe both, maybe substitution, maybe elimination. Let's practice at least one more. Maybe with each or whatever you want. You want elimination, you want substitution with nonlinear systems.
I would say elimination because I
Very-
kind of knew substitution. Like
Very good. Very good. Perfect. So we want to do elimination. Okay, very good. Okay, so let's look at problem 26. X squared plus y squared equals 5. And x squared plus y minus 8 squared equals 41. This is 26 on 587. Okay, so we can use substitution on this if we wanted to. We could use elimination if we wanted to, but we wanted to use elimination. So which of the 2 variables I can get rid of? There is not exactly. There is nothing I can do here. They're not the same. So the only option is to eliminate x squared. It doesn't matter which of the 2 equations we multiply by what? Negative 1. So since the top one is easier to work with, why not multiply the top by negative 1? So negative x squared minus y squared equals negative 5. And then x squared plus y minus 8, everything squared, equals 41. I add. Now I have to be very careful because I cannot add y minus 8 squared to negative y squared. I have to expand and then put minus y squared. So let's expand y minus 8 squared. And we know we have to write 3 terms. The first term squared, y squared, minus 2, yes, 16y plus 64. Now I copy the top one, the negative y squared. And then the right-hand side is 41 minus 5, which is 36. And everything is accounted for. Agreed? Okay, next. I will simplify, combine like terms, do everything I can, right, to get y. So these 2, luckily, are going away. Then I have negative 16y. This becomes a linear equation, so I have to move 64 to the other side. So negative 64 plus 36 is negative 28. Okay. And then y equals, very good. And I can simplify by 4. So y equals 7/4. It's good, but it's not good enough because now I have to go back and replace y, and I will get potentially how many solutions for x, but the same y? 2. Okay, so let's see. So we have x squared plus 49 over 16 equals 5. And x squared equals 5 minus 49 over 16. We have to find the least common denominator. So x squared equals 80 minus 49 over 16. Also, x squared equals, is it 31? I think so. So then x equals plus or minus the square root of 31 over 4. It appears that, and we can always go back and check, it appears that this system has 2 solutions. Y value is the same in both cases. The x value is, or the x coordinate is the square root of 31 over 4, and negative the square root of 31 over 4. Let's look at a word problem now. What about this one? Find the length and the width of a rectangle whose perimeter is 36 feet and whose area is 77 square feet. That's an option. Here's another. The difference between the squares of 2 numbers is 3. Twice the square of the first number increased by the square of the second number is 9. Find the numbers. Any preference so far?
I like the second.
The second one, very good. That's the problem 45 on 588. So let's read the problem. The difference between the squares of 2 numbers is 3. The difference between the squares of 2 numbers is 3. Perfect. Next, twice the square of the first number. What do I write? Very good. Increased by the square of the second number is 9. Very nice. This is clearly set up already for us for elimination, or the adding method. In some books, and even in this one, the adding or eliminating. You're adding, and the result is you're eliminating. It's up to you, either one. So this is 3x squared, and this is 12. I like it because x squared equals, very good. I take the square root, and I get 2 options for x. That's good, but it's not good enough. I have to go back now with x squared, which is 4. And I have 4 minus y squared equals 3. Therefore, y squared must be how much? If 4 minus y squared is 3, y squared must be only 4 minus is 3. Then we take the square root, and we get equals plus or minus 1. Also remember, when x is 2, y is negative 1, or positive 1. When x is negative 2, y could be positive 1 or negative 1. So how many solutions will we find here? 2, 1, 2, negative 1, negative 2, 1, and negative 2, negative 1. Any questions? Any questions? I know I have only 4 minutes. I just want to show you one problem from systems of inequalities. Again, this is a review. Not everything here is a review. So I'm going to choose a very simple problem, 34. You will remember when you see it. X plus y less than or equal to 4, and y greater than or equal to 2x minus 4. These are not equations. These are inequalities. How do I solve a systems of inequalities? Here's step 1. I look at the first inequality and I write the corresponding equation. And no, I'm not changing the inequality into an equation. I need to graph the equation first in order to graph the inequality. That's why I need the equation. I'm going to find two ordered pairs to graph this line. Okay, when x is 0, how much is y? Very good. So we have 0, 4. Obviously, when y is 0, how much is x? Good. So I have the equation that is corresponds to this inequality. So let's graph the equation first. 4, 0, 0, 4. Because the inequality symbol has the equal symbol, I will graph the line as a solid line. Otherwise, it would have been a dashed line. So this is x plus y equals 4. I see that it divides the entire plane into two regions, the region above the line and the region below the line. I would like to pick this point because it's the easiest to work with, and I'm checking this region. So 0, 0. I get that 0 is less than or equal to 4. Is this true? I will shade in. And I will say this represents x plus y less than or equal to 4. I will repeat the same steps for y equals 2x minus 4. Y equals 2x minus 4. When x is 0, how much is y? So 0, negative 4. And now when y is 0, I have, yes, 4 equals 2x, so x equals 2. So 2 comma 0. I go back, 0, negative 4, and 2, 0. The inequality symbol has the equal symbol in it, so I will graph it as a solid line. So this is, please do not forget to write y equals 2x minus 4. This is not the inequality. I see that it divides the plane in two regions. And again, I'm going to pick this easiest to work with, which is 0, 0. Is 0 greater than or equal to negative 4? If you say yes, I will shade in the region with 0. If you say no, I will shade in the opposite region. It is greater. So this is indeed y greater than or equal to 2x minus 4. So now, do the blue and red territories intersect? Because they intersect, this will be the solution. All points on this line, the vertex here, all points on this line, and everything in between will represent the solution to the system. Both inequalities at the same time.